Is everybody on this page? No? 311.
Somebody sitting beside yourself.
Who was this? Which computer was this found at? Okay, thank you. Okay, so we're talking about earthquakes. Guys, ow. Talking about earthquakes, so you guys have probably heard of magnitude, right? Richter scale? Heard about this in science, probably. So what it's talking about, it's just saying Charles Richter used to measure magnitude of an earthquake. Earthquakes measure amount of energy released determined from the logarithm of an amplitude of waves recorded by seismographs. So Richter scales are logarithmic, so that's why we're using it in this unit. Difference in 1 unit in magnitude, so you might want difference in 1 unit in magnitude corresponds to a factor of 10, what is that called? Difference in intensity. Okay, so every 1 unit in magnitude is 10 times different in intensity. Okay, so one whole number represents tenfold increase in intensity. So if I go from, is that Logan? Therefore, so a magnitude of 9 is 10 times larger than a magnitude of 8. Does that kind of make sense? 10 times larger intensity. Logan, you're writing your quiz today, right? Yep. It is, just give me a sec. Right here. And then tomorrow you have your unit test. We said tomorrow. I have it written down for tomorrow. You're writing it tomorrow. Well, you're going to have to study tonight then. This means that each whole number step represents tenfold intensity. So I talked about that. So magnitude of 1 on the Richter scale is equivalent to a large blast at a construction site using approximately, guys, 14 kilograms of TNT. You guys okay? What? You guys have questions, or you doing okay? Okay, so knowing that, let's try to do some of these. So earthquake of magnitude of 8 is how many times as intense as a magnitude of 7? Yep. So there are 1 magnitude apart, so it is 10 times more, right? 8 is greater than 7, so it's 10 times. So an earthquake magnitude of 7 is how many times as intense as magnitude of 3? What? 10,000. 10,000. Because 7 minus 3 is 4. Yeah, so we 10 to the exponent 4. It's just 10,000. So if I'm going the other way, so 4 to 6, 4 is less than 6, right? So how many place values away are there? So 4 minus 6 is what? 4 minus 6 is what? 4 minus 6. Negative 2. It's a negative 2. We talked about negatives, so it'd be 1 over 10 squared. 1 over 100. You see where I went there? Does that make sense? So magnitude of 4 is 1 over 100 times as intense as a magnitude of 6. What about 4.8 to 6.8? What is the difference there? Yeah, it'd be negative 2. So what will my intensity be? Yeah, same thing. Okay, so 1960 earthquake in Chile was how many times as intense as the 1976 earthquake in Italy? So let's look up here. So we have Chile up here. Was it 1960? Oh, we have 2. 1960 and 1976. So 1960 is 9.5. And then 6.5 is in Italy. So how much more intense is it? Okay, guys, focus. I have the earthquake in Chile is how many times more intense as the earthquake in Italy? Yeah, so it's 3 place values away. So we 10 cubed, which would be 1,000. And then how much more intense is the 1983 earthquake in Colombia? It's right here. So now we're comparing Chile. Yes, so now we're comparing Chile and Colombia. So there's 4 magnitudes, which is, 10,000. So 3 10 to the 4. The 1966 earthquake in Turkey was how many times as intense as the 1933 earthquake in Japan? Turkey. So we got Japan up here. We got Turkey down here. So we're going from Turkey to Japan. Will this be positive or negative exponent? It'll be a negative exponent. So it'll be how many place values away? So we 10 to the negative 2, which will be what? Do we have any questions on this, you guys? No. So if I give you questions like this on a test, I will give you either that scale or I'll give you magnitudes. So you just have to know that a magnitude is tenfold. So if I give you a magnitude of 1 or magnitude difference of 1, then it is an intensity of 10 times more, okay? So you might just have to, that's all you're going to have to know. So you just have to know that magnitude is tenfold. Okay, any questions? Comparing earthquake intensities. Seeing how to compare intensities of earthquakes using magnitudes differ by an integer. So how could we compare them when the integer isn't exactly 2 place values or 3 or a whole number place value away, okay? So this is how you would compare them. So magnitude of earthquake given by the formula. M equals log of I over I naught. I is your earthquake intensity. I naught is a reference intensity. Okay? So M1 equals log of I1 over I naught. M2 equals log of I2 over I naught. So put them together into this formula. M1 minus M2, so the magnitude of your first earthquake or whatever minus the magnitude of the second equals log of I1 over I2. So this M1, this would be your intensity of the first one. Okay, this M2, this would be your intensity of the second one. So you just have to be consistent with those two. Okay? I am recording. I've got this. Okay, so M2 minus, or M1 minus M2 equals log of I1 over I naught minus log of I2 over I naught. So let's complete this work, okay? So it's going to equal this somehow. We just have to get there. These are using our log laws, okay? So if I am dividing 2 arguments, what is that the same as? Subtracting, perfect. So log of what minus log of what? Yep. Log of I naught minus
log of I2.
Do you guys remember this?
Yeah.
These are just your log laws. Yeah, so these right here, these are divided, so you're going to subtract them. So the top one is the first, minus the bottom one would be the second.
So the thing right behind it.
So it would be log of this minus log of this. This is just your quotient law for logarithms. Same with this. So you're subtracting. When you're subtracting, put this all in brackets because you're actually subtracting a negative, which when we take out our brackets, we have log of I1 minus log of I naught minus log of I2. When you subtract a negative, what is it the same as? Adding. Plus log of I naught. Is there anything here that we can cancel? Bless you. Is there anything here we can cancel out? Yeah, so I'm subtracting the log of I naught and adding the log of I naught, so I can cancel those two out. Yeah, so this is just equal to log of I1 minus log of I naught, or I2, sorry. Okay. Are there any questions with that? Let's use our quotient law and put this all together now. So if I have I1 minus I2, if I'm subtracting two logarithms of the same base, can I do something with the arguments? Sorry, I think I heard it.
Arguments?
If I'm subtracting two logarithms, what do I do with the arguments? Yeah. So all of this actually just turns into log of I1 over I2. So this is just proving why it goes to this. So this is just our proof. Yeah. And using so this is just practice with your log laws and proving why your M1 minus M2 is equal to log of I1 over I2. Okay. Any questions, you guys? No? Okay, so if I have the equation M1 minus M2 equals log of I1 over I2, to change this to exponential, you can get I1 over I2 equals the 10 to the M1 minus M2. So those are just converting between logarithmic and exponential. Okay, I will give you those in an exam. So they can be compared using that or that, either one. Okay. Okay, so let's do a question with it. How many times more intense was the 1960 earthquake in Chile with a magnitude of 9.5 than the 2005 earthquake in Chile, magnitude of 7.8? Answer to the nearest whole number. So let's use this formula right here, because if we're looking for how much more intense, we want to find our I1, I2, okay? So I1 over I2 is equal to 10 to the M1 minus M2. Okay, so I1 over I2, this all right here is just telling you the intensity, okay? Don't get confused with I1 over I2, because that all together will be your intensity. You're not dividing anything, okay? So we have our I1 over I2 equals, so if we're talking about how much more intense was one over the other, you're always going to put the first one in your M1, okay? So if I'm talking about, so I have 10, it's an exponent. If I'm talking about much more intense to Chile in 1960 over the earthquake in Chile in 2005, I'm going to put the 9.5 first. Do you guys understand that? So if I'm talking about how much more intense that one is, you put 9.5 first minus 7.8. What's 9.5 minus 7.8? 1.7. What is 10 to the exponent 1.7? Okay, so if it's asking for the intensity, how do you answer this? If you got 50.12, so then to finish this question, you would say it was, you would round this, you just round this to the nearest number, so 50 times more intense. Yeah, that's not how any of those jokes. It's 50 times more intense. Do you guys understand where we went there? So if you're looking for intensity, use this formula, okay? I1 over I2, this right here is just this one number, okay? So you're not finding I1, you're not finding I2, you're finding the intensity. So that altogether is your intensity. So all you have to do for this one is go 10 to the m1 minus m2. So just take your magnitude of the first one minus your magnitude of the second one. Okay. So you can see here, if it was switched, so if it was determined the 2000, how much more intense the 2005 earthquake in Chile was over the 1961, you would just switch this 9.5 and 7.8. It would be a negative. So then that would change your intensity level, okay? So always just do the first one first. So if it's a negative exponent, it'll just change your intensity level. Okay. Any questions, guys?
So if it mentioned the 2005 Chile earthquake first.
Yeah. So if it mentions the 2000, I'm just going to put this in red. If it mentioned the 2005 one first, it would be the same setup, except your M1 and your M2 would just switch. So it'd be 10 to the 7.8 minus 9.5. That's the only difference. So whatever one's mentioned first would be your M1. Yep, absolutely. Okay. Is everyone okay with that so far? Okay, now we have a major earthquake of magnitude 7.5. Is 375 as intense as a minor earthquake? So is the magnitude of the minor earthquake, greater or smaller than 7.5? So if it is a major earthquake is 375 times as intense as the minor one, is the minor one greater or smaller than it? What do you guys think? Smaller. Why? Okay, so your minor earthquake is going to be smaller than your major earthquake. That's basically what they're getting at. Does that make sense? Because this right here, if it's greater than 1, this is going to be bigger than your second earthquake, okay? Okay. So use this formula to determine to 1 decimal place the magnitude of the minor earthquake. Okay, so we have our intensity. I1 over I2 is equal to 375. What's your M1? 7.5. Do we know our M2? So let's substitute this into our formula. So we have 375 equals 10 to the 7.5 minus M2. Does everyone see where this came from? Okay, so as soon as I have the variable and the exponent, what did we do yesterday to solve for that variable? Yeah, change it to log. Did you? Sure. Okay, so change it to logarithmic form. So every time you're looking for a variable that's in an exponent, change it to logarithmic form. Okay? How would I change this to logarithmic form? So I have log base. Then, what's my argument? Good. Does everyone understand where that came from? So it's just changing exponential form to logarithmic form. You're going to have to know this for Friday. Oh yeah. I'm going to be gone Friday, so I'm teaching our new unit Thursday, and then you'll write up Friday instead. Yeah, I just found out I'm gone Friday yesterday. I have a video conference meeting, actually, in Vermilion. Okay, so how would I solve for this? Isolate M2. Am I dividing? Always do the opposite operation. So if it's in front, yeah, if it's in front, it's positive. So let's just subtract. So I have log. Do I have to write base 10 if it's logarithm? No. So you just go log of 375 minus 7.5 equals a negative m2. Okay, so don't forget to carry down this negative. So you can put this right into your calculator. Is everyone with me so far? So log of 375, close your bracket, and then you're going to subtract 7.5. You guys got a negative? Good. Because you're going to have a negative 4, what does it say, to the nearest 1 decimal place? What would I round this to? 1 decimal place. Yeah, negative 4.9 is equal to what? Positive or negative m2? Negative m2. Yeah, so 4.9 is equal to m2. So you're just going to have to be careful with your negatives. Because since we added, this negative here becomes this negative. You just either multiply by -1 or divide by -1. So you can, if one side's negative and the other side's negative, you can just make them both positive. Sorry, what are you guys asking? You could put a base of 10 here if you wanted to, but with a logarithm, if it's a base of 10, you don't have to write the 10. Because if you have log of 375, if I just put it in my calculator like this, it's already a base of 10 there. If you have a base of anything but 10, that's when you would divide by that log. Okay? If you don't remember that on a test, if you put log of 375 divided by log of 10 and then subtract 7.5, you'd get the same answer. Are there any questions about how to find your magnitude here?
If we wrote it just in the negative form instead of...
It's going to be multiple choice. It might have that negative 4.9 there. Make sure it's a positive. Yeah, so it will catch you. It'll probably have that, yeah, negative 4.9 to throw you off, to make sure you know that this negative is equal to this negative, so they're both positive. Yeah, so it'll be the same format as before. With the negatives, okay, so you know this log of 375 minus 7.5 is equal to negative m2, right? Yeah, you're okay with that so far? Because this negative in the 7.5 minus m2 will transfer down. So this log of 375 minus 7.5, that'll be a negative 4.9. So you have a negative 4.9 is equal to a negative m2. If they're both negative, you could just multiply both by -1. And then get a positive 4.9 is equal to a positive m2. Does that make sense? Okay, so this m2, it's going to have to be, there can't be any negative. So if you're ever isolating a variable, it can't be negative, it can't be multiplied by anything, it has to be just by itself, okay? Okay, any questions, guys? Okay, so let's talk about loudness of sound. So you guys have probably heard of bells or Alexander Graham Bell. So current unit used is called the decibel, equal to 1/10 of the bell. Okay. So the Bell scale, like the Richter scale, is logarithmic. So a difference of 1 bell or 10 decibels corresponds to a factor of 10 difference in sound intensity. So it's the same idea. What? What? So a leaf rustling, 10 decibels or 1 bell, is 10 times as intense as the threshold of hearing. Because if you look at the threshold of hearing, it's right at the bottom, and a leaf rustling is right above it, then it would be 10 times more. Okay? A whisper, which is 30 decibels or 3 bells, is 10 to the exponent 3 or 1,000 times as intense. So same idea as magnitude, Richter scale, okay? So let's look at this. If I have a power saw, which is 120 decibels, it's how many times as intense as a telephone dial tone, which is 80 decibels. So if I have 20 decibels, how many bells is that? Or 120 decibels. Decibels are 10 times as big as a bell. Yeah, so it's equal to 12 bells. And if I have 80 decibels, what is this equal to? How many bells? So what is my difference here? 12 minus 8? 4. So my intensity is 10 to the exponent 4, which is what? What's 10 to the exponent 4? Yeah, 10,000. Do you guys see what I did there? So I take my decibels, convert them to bells, so just divide them by 10, subtract them, and then that's my exponent with a base of 10, okay? Okay, so let's try this next one, guys. If I have 145 decibels, how many bells is this? Yep. And if I have 125 decibels, how many bells is it?
12.5.
So what's 14.5 minus 12.5? So my answer is going to be 10 to the exponent 2, which is what? Any questions so far, grade 12s? Okay, so you guys tell me what to do on this next one.
Okay.
Oh, man.
You switch
30 decibels,
3 bells.
3 bells. Okay, now somebody else tell me the next step. Yep. Do I go 6 minus 3? Yeah, so I already started with the first one. So go 3 minus 6, which is equal to what? What's 3 minus 6? So we 10 to the negative 3, which is equal to? Yeah, 1 over 1,000. This goes right here. It's not going to fit.
Okay, so
So go 10 to the exponent negative 3, and then go math fraction. Was it?
0.001.
It's not going to a fraction? Yeah, it did. Okay, are there any questions with how to do this? The biggest thing is changing from bells to decibels, so just divide by 10, okay? But if you see here, there's two different there's two different formulas here, okay? So we can measure for bells. Bells equals log of I over I naught, or decibels equals 10 times log of I over I naught. Again, these formulas will be given to you on an exam, okay? So we can use either one depending on what the question gives you, okay? If I am mean, I could give you decibels and give you only the bell formula, but I don't think I'll do that because I'm not mean. Whoa. No one should be touching anybody's stuff.
Sorry. I'm sorry.
Okay, anyways, back to math. Okay, guys, focus. These are the same ideas. If they aren't exactly like two full or whole numbers away from each other, we can still figure out using these formulas. So how many times more intense is the sound of a piano playing at 67 decibels than a whisper at 22 decibels? So if I'm looking for intensity, am I going to use my logarithmic function or my exponential function? If I'm looking for intensity, Use the one where it has intensity on one side. So use your exponential. Okay, so you're going to use I1. Oh, and am I going to use my decibel one or my bells?
What?
Am I using decibel? Yeah. So what is my formula for decibels? Yeah. Equal to those numbers over there. So we're going to use this one because we're looking for intensity, and intensity is on our one side of the equal sign, so that's good. And then we are using decibels because that's what was given to us. So this is why we're using this formula, okay? So if I have I'm looking for my I1 over I2 equals 10 to the exponent. What's my first decibel? What's the first one? Yeah, 67 minus 22. Don't forget to divide that by 10. So 67 minus 22 divided by 10. 4.5, so it'll be 10 to this exponent.
Whoa,
That's what you guys got?
whoa, man. Dylan doesn't even put his
Doesn't even, yeah, looks about right. If it's asking for intensity and it doesn't say, just round to the whole number. So what is the whole number here? Round up?
1,623.
Yeah.
That's so
Okay. So is this what you guys got? Do you agree?
That was clever. You're funny.
That was pretty funny.
There you go, Dylan.
Okay, so let's do this next one quick. Given that decibels equals 10 log of I over I naught, show that the decibel level for the threshold of pain, 125. 125 decibels has a sound intensity, 10 to the 12.5 I naught. Okay, so first off, we're using this formula. Do we have decibels?
We don't. We just do.
How many?
125.
Okay, so you have decibels of 125, and then do we have an intensity?
Yeah.
As what?
10 to the power of 12.
Just wait. Show the decibel threshold of pain has a sound intensity of that. We're going to show that it has that. So this is what we'll look for, okay? So we have 125 equals 10 log of I over I naught. So we have to show that this with that decibel is equal to this.
And are we just going to change that to log I minus log I naught? Or I naught, right?
Okay, well, so right now we're going to solve for I over I naught and then show that it's equal to that, okay? So what is my first step to solving for I over I naught?
Get the log on the other side.
No. Do you remember doing this yesterday?
You make it. Don't you make it into a. No.
Get rid of the 10.
Divided by 10.
Divide by 10. Okay, so I have 12.5 equals log of I over I naught. How do I solve for my intensity now? Guys, why are we yelling? I have a video conference call going on. Keep it down, please. Jeez.
Shut up.
Okay, I have 12.5 equals log of I over I naught. How do I solve for this?
Now you make it into a log. Better one.
It's already in a log.
Are you
Change it to what?
Oh, exponential.
Change it to exponential. Okay, what's my base? If there's no base beside a log, what is it always going to be? 10. What is my exponent? 12.5. What's it equal to?
Be nice.
Okay, so can we get, guys, can you pay attention, please? We're almost done this. I have 10 to 12.5 equals I over I naught. Can I isolate the I? It's being divided by I naught. What's the opposite? Multiply. Multiply both sides by I naught. So I have 10 to the 12.5 times I naught is equal to I. Is that exactly the same? So that's just showing that that is equal to that. Okay. Any questions so far? Is it making sense to you guys? So the biggest thing here, you guys, is to be able to solve. So if you are in exponential form, if you're looking for an exponent that's a variable, change it to logarithmic. If you're in logarithmic and you're looking for that argument, change it to exponential. So basically, this is practice going between exponential and logarithmic functions. Yes. I'll tell you after. So let's do pH quick, and then we'll be done for the day. Hopefully, it won't take us long. So pH, same idea, okay? Similar to Richter and pH, difference of 1 unit pH corresponds to a 10 difference. So these are all tenfold, okay? Tenfold. So let's just go right into this. If I have tomato juice, guys, tomato juice is how many times more acidic as pure water? So look at tomato juice is right here. Pure water is right here. What? The biggest thing here is if it's talking about acidity and alkaline, it depends which way you go. So if it's asking how much more acidic is it, it would be 7 minus 4, not 4 minus 7.
7 minus 47?
Yeah. So you always go with the more alkaline minus the acidic, because acidic pH is less than 7, right?
So it's 3.
Yeah. So if it's ever here, if it's ever less than 7, it's more acidic. If it's ever greater than 7, it's more alkaline. So if I'm asking more acidic it is, you're going to have to do the opposite by subtracting. Does that make sense? If I'm asking alkaline, you'll have to go the same way. So if I'm asking the acidity, it would be 10 to the 7 minus 4, or 10 cubed. Does that make sense, you guys? Lucas and Ben, control yourselves, or I'm going to split you up, please. So 10 cubed, this is 1,000. So if I'm asking eggs are how many times alkaline is pure water, what you do here is you look at pure water, you look at eggs. If I'm talking about alkaline, go backwards again, don't you? How many times more alkaline? This one does get confusing. If I'm asking for acidity, if it's more acidic, then you would go the opposite. And if I'm asking for alkaline, if it's more alkaline, then you would go the opposite. Is that? Okay, so if I'm asking for acidity and whatever is more acidic, so if its pH is less, then you would do the opposite. If I'm asking for alkaline and it is more alkaline, then you would go the opposite as well. So this right here would be 10 to the 8 minus 7. So it should be just 10. So this does get confusing. So if it is more alkaline, then you go the opposite. If it's more acidic, you go the opposite. If it's less, you would go. If it's less. So if I'm saying how much more acidic is water than vinegar, then you would go 4 minus 7. Right? Because water is more alkaline than vinegar. So then it would be the opposite.
Take the more alkaline one.
Yeah, so you would take the more. So if I'm asking how many more times eggs or how many more times is alkaline as pure water, I know eggs are more alkaline than pure water because it's a bigger number. So you would go 8 minus 7. If it was the opposite, if pure water was more alkaline than eggs, then it would be 7 minus 8. Okay. So, now you have eggs are how many times as acidic as pure water. So now it's the opposite, okay? So it's the same, these two are the same, except the only thing that's changing is these two words. So if I'm talking about acidity, I know that water is more acidic than eggs, so I put my water first. So this would be to the 10 to the 7 minus 8. You see the difference here?
Yeah.
So yeah, this would just be 1 over 10. Milk of magnesia, down here, is 1,000 times as blank as blood. So is it more alkaline or acidic? Is 1,000 times more? Would you say alkaline or acidic? So look at blood, look at milk of magnesia. Which one's more alkaline?
Oh, no, it's more alkaline.
Yeah, so this would be more alkaline. I don't know. I'm a math teacher. What is 1,000 or 100 times as acidic as normal rain? So you look at normal rain. What is 100 times as acidic? Yeah, how do you know? So look at normal rain. If you're looking at something that's 100 times more acidic, go 2 place values above it. So it would be vinegar. You guys with me still? Kind of, sort of. Eggs are 1 over 10,000, which would be 10 to the negative 4, times as alkaline as, okay, so these are 10 to the negative 4, so 4 place values away as alkaline as, which way am I going? So if I have a negative exponent and I'm talking about alkaline, finish? So you have a double negative here. Do you lose your lunch kit again?
No, should I pick some mac home and just look over it?
Probably a good idea. Okay. Eggs are 10 to the negative 4, or 1 over 1,000, as alkaline as what? So if you're looking at this, you're going 4 place values away. What? You would actually, guys, focus please. You'd actually go down here. So as alkaline as washing soda.
Oh, okay, yeah, that makes sense.
Yeah?
What's the difference?
Yeah.
What's so funny?
Because eggs are, if you do the opposite, it would be 10 to the 4 as acidic as washing soda, right? Guys, focus. If it helps to do the opposite, that works. So eggs are 10,000 times as acidic as washing soda. So if you do the opposite for both, so they can be 1 over 10,000 times as alkaline. Okay, so if you have to do the opposites to figure it out, then I'm okay with that. So study.
So I'll just eat your orange juice.
Okay, so let's do these really quick and we'll be done. Okay, guys, focus, please. We need to get done this. We're almost done. We're almost done. Okay, so find how much more acidic or alkaline one solution is to another. Use P or 10 to the exponent of pH 1 minus pH 2. So pure water, swimming pool water, and seawater have pH levels of 7, 7.5, and 8.4 respectively. Seawater is how many times as alkaline as pure water? So we're going to use 10 to the pH 1 minus pH 2. So if I'm talking about seawater, so this is pure. I'll just write it over here. So pure is 7. Swimming is 7.5. And C is 8.4. So I'm talking about seawater and pure water. Is seawater more alkaline or acidic as pure water?
No, it's more acidic.
Seawater is how many times as alkaline as pure water? Is seawater more alkaline than pure water?
Yeah.
Yeah. So do we just go the normal way or do we go opposite if it's already right? If it's already good, then you do the regular way. Okay, so this would be 10 to the 8, this way. 8.4, yeah, so it'd be 10. So since it's already more alkaline, you just go 10 to the 8.4 minus 7. Okay. 10 to the 1.4. What is this equal to? Seawater is how many times as alkaline as swimming pool water? Is seawater more alkaline than swimming pool water? If it's more alkaline, do we go seawater minus swimming pool water then? Yes. If it's already right, just leave it. But if I say seawater is how many times as acidic, then you would do the opposite. What is 10 to the 0.9? 7.9. Yeah. Guys, focus, please. Do you have any questions about this? If it is more alkaline, then just leave it. If it's the opposite, then you would do the opposite, okay? So these ones were both the same, so you just leave it. Yeah, so if I say seawater is how many times as alkaline as pure water, I know seawater is more alkaline than pure water, so that's good, so I leave it. If I were to say seawater is how many times more acidic as pure water, then I would go the opposite. Then I would go 7 minus 8.4. Okay? pH of a solution is defined as pH equals negative log of your hydrogen ion. So a patient given urine sample found to have a pH of 7 or 5.7. What was the hydrogen ion concentration? So I have 5.7 equals negative log of H plus. So if I'm trying to find my hydrogen ion concentration, let's get rid of that negative. So if I divide or multiply by a negative 1, yeah, so you just make the opposite side. Sorry? You good? So what do I do now to find my, if I'm looking for my argument, what do I change it to? Yeah, so what's my base? Yeah. What's my exponent? Good. So I'm not going to worry about that. You can put that in your calculator. Let's just do this next one. So if I have the pH, or define the pH of solutions in the nearest tenth, if the hydrogen ion concentration is 3.4 times 10 to the negative 4. So this we just do the opposite. So you have pH equals a negative log of 3.4 times 10 to the negative 4. And then you just put that right into your calculator. Okay, so this was kind of an intense lesson, but